Here we go. Number 3 reads, the captain of a plane wishes to proceed due west. The cruising speed of the plane is 200 meters per second relative to the air. A weather report indicates that a 30.5 meter per second wind is blowing from south to north. In what direction, measured with respect to due west, should the pilot head the plane relative to the air? On these vector problems, these aren't normal 4-step problems. Everything is in step 1. It's all in your picture in terms of what's going on. And the first thing we want to define is, which way do we usually call up on a page? We usually call that north, right? Down is south, to the right is east, to the left is west, okay? That's just so we're all consistent and we're on the same page then, okay? So in this case, this pilot in the airplane, they're just trying to fly due west. So maybe, for spring break, the plane is trying to fly out to California, something like that, okay? We're trying to fly due west. And normally, the velocity of the plane is given as 270 meters per second, okay? Now the problem is, there's a wind blowing from what? South to north, right? 30.5 meters per second. So the problem is, if this wind is blowing upwards, right, 30.5 meters per second, is the plane going to fly due west? Or it's going to fly off course? It's going to end up flying what? Yeah, it's going to end up going in the northwesterly direction, right? That's not what we want. So using common sense, which way would the pilot angle the plane so it still flies straight west? It's going to angle the plane what? Yeah, in the southwesterly direction, okay? So in order to get the plane to fly in the southwesterly direction, we're going to have to angle the plane downwards. Okay. So the question is, how much do you actually angle it to the southwest? What's this angle going to be? That's what we're really solving for, okay? So you see how these problems, it's not the math that's hard. I know you know how to do geometry, right angle geometry, a squared plus b squared is c squared, and then sine, cosine, tangent. What's hard, quote unquote, is just trying to picture what's going on. Once you get the picture down, you'll nail it, okay? So we got to find that angle. We know the plane can normally fly how fast? 200 and what? 70 meters per second. That's the hypotenuse, okay? How fast is the wind blowing? It's blowing straight north how much? 30.5 meters per second, okay? So if we line up our vectors correctly, then the resultant is always where you start to weigh up. This will be the resultant, okay? It'll be due west. But in this case, we don't really care what the resultant is. We're not trying to find its size or its angle, which would be straight west, okay? What we want to find is that angle theta. So now it's actually pretty easy, okay? If I want to know theta, which trig function relates the opposite side to the hypotenuse? This is the opposite side, this is hypotenuse. The sine function, that's correct. The sine of theta is the opposite over hypotenuse, okay? So the opposite side is 30.5. The hypotenuse is 270. So how do I just get theta by itself? I'm going to take the what? The inverse sine, right? Inverse sine. So let's go ahead and get out our calculator. And if we get out our virtual calculator, right here, I'm going to make sure that, really quick, make sure you're not in radians, but in what? Degrees, okay? So that's just a common problem if you're taking trig. When you go back to your trig class, switch it back to radians so you don't get screwed up, okay? So I'm going to quit out of there. And then I'm just going to do the inverse sine, okay? If I want to get just this angle, theta, theta will just be the inverse sine, right? Sine to the negative first of 30.5 over 270, yeah? Is what I'm trying to break down there. So if I do the inverse sine, second sine of 30.5 divided by 270, I'll get my final answer of like 6.486. Let's give it 3 sig figs. 6.49 degrees, okay? So my final answer is just 6.49 degrees, and I'm going which general direction to get the plane to go the right way? South of west. That's correct, okay? 6.49 degrees south of west. So in other words, normally an airplane will not fly in the direction you want to point it because there's wind blowing, okay? So in real life, a pilot needs to check the weather report to see which way the wind is blowing. If you know the speed of the plane and the plane speed of the wind, you can put in a course correction so that you end up flying where you want to fly, okay? And in real life, this happens all the time. Now, what's nice is with all the technology, a computer will do it, but every pilot has to be trained to do this in case your computer breaks or whatever, okay? So in a nutshell, that's number